the data for this logistic regression part on risk behavior is wearing seatbelt, right, or not. Okay, so the survey question was, did not wear seatbelt last time driving a car. So 0, wear seatbelt. 1, not wearing seatbelt. So you're trying to find the possible factor that are affecting this risky behavior, not wearing seatbelt. Okay, so 1 indicating not wearing seatbelt. That's a behavior we would like to see, all right? And so we have 3, actually they are all categorical variable, right? But you know that when you do this, your risk factor or explanatory variable can be categorical or quantitative, okay? You can have age that is numeric, right? But this data happen to be all categorical, but that's fine, okay? So the data is over here. So let's download this data. Click OK. So it's in the Excel file. So if you look at this Excel file, seatbelts, gender, race, and live on campus or not, right? So that's good. So what I'm going to do is actually I'm going to import this data, right? So you have this data downloaded. You want to import it to SPSS. So let's open SPSS. Okay. Now click File, Open Data. I want to open the Excel file. So that data file that we just had, right? That's good. Open. So they all line up pretty well. That's okay. Good. So we have the data entered. Okay. 1 is not wear seatbelt. 0 is wear seatbelt. All right. So we're going to label these variable. 1, not wear seatbelt. And 0, wear seatbelt. Okay. So that's the wearing seatbelt variable. And the gender, 1 is for male, 0 is for female. Okay. And race, I should okay this, right? And then go to this. Okay. 1 is for Y. 2 is for black. Oops. And 3 is for other. And then click OK. Live on campus. So 1 is on campus, right? And then 0 is off campus. 1 on campus. And 0 off campus. Okay. Good. So I have my data ready and properly labeled. That's good. Okay. So let's look at the first question. First question actually just asks you to find the raw odds ratio of not wearing seatbelt. This is for male versus female, and we want one for Y race versus other race. We also want live on campus versus off campus. Okay. So that's good. So this is raw odds ratio. In fact, you can get it from cross-tabulating, right? So usually I like the risk factor to be row variable and outcome response variable as a column variable. Okay. If you recall how to get the odds ratio, click statistic and then click on risk box. Continue and OK. So we have wear seatbelt, not wear seatbelt, female and male. So this odds ratio is the odds of this first one. All right, it's lower value, odds of wear seatbelt for female versus male. Okay, so odds for wearing seatbelt for female versus male is 2.34. That means female, all right, is more likely to wear seatbelt than male. All right, so male is more likely not wear seatbelt. So if you want to find the odds ratio of not wearing seatbelts, okay, for male versus female, you're flipping these two categories. You also flip these two categories. Then this number also is the same. Is the same, or the odds ratio should be the same. The odds of not wearing seatbelt for male versus female is 2.03. So this means what? If you're a male, right, you're more likely to not wear seatbelt with the odds ratio of 2.034. Please don't say that if you're male, you're about 2 times more likely, right? Or 2 times as likely as female to not wear seatbelt. This is ratio odds. So if this is ratio probability, like if this is relative risk, and you can make that statement, right? But this is the odds ratio, so you can only say that the odds of male not wearing seatbelt, 2.3 or 4 times the odds of female not wearing seatbelt. Okay, this is the odds, raw odds ratio. And in fact, if you run a logistic regression, binary logistic regression, with the gender variable only, the logistic regression will give you odds ratio, right? That odds ratio will be exactly the same. So let's do this. Let's just run the binary logistic regression, right? Analyze regression. To run binary logistic regression, you check binary logistic and choose seatbelt as a dependent variable, gender as a covariate. Okay. Remember, gender has value 1 or 0. 1 is male, 0 is female. Seatbelt has two value. 1 is not wearing seatbelt, 0 is wearing seatbelt. All right, so keep that in mind. Click OK. So this is the logistic regression output. It'll tell you how the dependent variable coded. So not wearing seatbelt is 1, wearing seatbelt is 0. Okay. The logistic regression actually help you to model the probability of 1 to occur. Okay. So the 1 to occur in this case is not wearing seatbelt. Okay, so keep this in mind. And then it actually give you if you watch my video, it actually give you something similar to R-squared in the multiple regression. Okay, and let's go down further. Okay, it give you this table, coefficient estimation table. So this table looks very similar to regression result from linear regression. You have a variable that you include and also the constant term. Okay, and the odds ratio for gender is 2.034. That's really what we just saw earlier when we look at that contingency table. But here, the odds ratio is odd because gender code is 1 and 0, right? 0 is the reference category. So this odds ratio is odds of actually not wearing seatbelt for male versus female. Okay. Because gender variable has value 1 and 0. 0 is actually base category. So this is actually the odds ratio of whatever behavior, right, indicated in the response variable. For gender variable, 1 versus 0, 1's male. So male versus female. So that's 2.03. And of course, you can do this for the other variable, right? You can do this for race, live on campus or off campus. Click OK. Actually, you probably are not able to do this for the race variable because race has actually 3 categories, right? Now, SPSS only do the risk analysis for 2x2 table. So for 3 category, it's okay. You can actually figure it out. Did I ask you that? I probably have asked you that, right? You can just click Analyze, Descriptive, Cross tab. Let me take the seatbelt out and live on campus, off campus out. Just leave the race in there and click OK. You get the contingency table, okay? I'm sorry, I did it too quick. Cross tab, not the gender. Gender, yes, race, take it out. Put it in here, right? Take the gender out. Put the seatbelt here. Remember, the outcome variable is a column and the risk factor is a row, right? So if you want to study the odds ratio for consider race variable as the predictor or risk factor, you click OK. You have the contingency table here. So what I ask is, let's see, why race versus other race, right? So if that's asked, right, you can just use a frequency for Y race versus other race. not wearing seatbelt. It's 77 over 217. So let me bring up a Excel worksheet, okay? And just use the information in the contingency table, you can do that odds ratio calculation. So let me do this. So we have Y versus other. So the odds of Y not wearing seatbelt is 77 over 216, okay? And over the odds of other race not wearing seatbelt, that's 5 over 32. Hope you're following. All right, 77 over 216, that's odds of not wearing seatbelt for Y. And 5 over 32, that's odds of not wearing seatbelt for other race, right? So the ratio of these two odds, you get 2.281. So that's the odds ratio for Y race versus other race. Okay. Now you can calculate for black race. If you want to calculate black race for other race, that's 14 over 55 divided by 5 over 32. So that's a black race versus other race. Okay. So this makes sense. You can do it by using these frequency table. Make a contingency table first, and then do this calculation using this joint frequency table. Or you can use logistic regression, logistic regression to do this. All right. By the way, before I do that, what if I ask you the odds ratio for Y versus black? Now, if you have these two numbers here, you have Y versus other and black versus other, then the ratio of these two, in fact, if you use Y versus other divided by black versus other, that actually gives you the odds ratio of Y versus black, because while you're doing this division, the other race in the denominator for both terms, they will cancel out, right? So in case, if when you run logistic regression, for instance, you find out that you would like to have a odds ratio of Y versus black, but the logistic regression result didn't give you that, right? It only gives you the Y versus other and black versus other. You can take a ratio of these two. That would be the odds ratio of Y versus black, all right? That's just something on the side since I had this. Okay, now, if I use logistic regression, random logistic regression, actually I can generate this without making this table, right? So if I do that, I click Analyze. Let me make this table a little bit smaller. Okay, Analyze, Regression, Binary logistic regression, seatbelt. I'm going to take this out and put the race in there, right? But be careful, because rate variable is a categorical variable. When you're running this multiple regression, having a categorical variable, you cannot use its original value 1, 2, 3. You have to set up indicator variables, right? So fortunately, in logistic regression, it has this function categorical button, allow SPSS to help you automatically set up indicator variable for this race variable. So you just put that in, and by default, it is set as indicator variable, right? You click Continue, and then click OK. It'll run the logistic regression, and here it'll tell you how they set up indicator variable. So again, the response variable value 1 is not wearing seatbelt, 0 is wearing seatbelt. And they set up indicator variable, parenthesis 1, all right, that's for indicating Y race. Parenthesis 2 indicating black race. So that's good. It both takes on 0, that indicating other race, all right? So 2 indicator variables is good for setting up a categorical variable in the model that has 3 categories. So that's great. Now we can go down to the regression estimation table, okay? Look at this number here. Compare this. This race 1, actually, remember race 1 is indicating Y, okay? Race 1 indicating Y, race 2 indicating black. So Y race versus other race, the odds ratio is 2.281, exactly what we got there. And the black race versus other is 1.629. That's 1.629, all right? So you don't really, if you know how to run logistic regression, in fact, you can actually do this odds ratio calculation so quickly, just run it, all right? Without having to set up a contingency table and try to do the calculations yourself, right? If you understand this logistic regression or know how to use it. Okay, so that help you to solve this first question, right? You can report the male versus female, the odds ratio, white races versus other race, and live on campus versus off. I didn't do this, but I think you can do that, right? Simply just drop that race and then bring in the off campus, on campus. Now, live on or off campus, it is a categorical variable, but it has value 1 and 0 already, right? Just like male versus female, it has value 1 and 0. It's an indicator variable, so you don't need to set up use a categorical. I mean, you don't need to do this. You don't have to do the categorical, right, for gender and live on campus because their values are already 1 and 0. Okay, but if you want to do it, that's fine too. Once if you've done it, you have to read the SPSS output to see how they set up indicator, which category the indicator variable is indicating, right? So it's important that you know that. So I know gender is 1 and 0, 1 for male and 0 for female, and live on campus 1 and off campus 0. So I'm fine, okay? So I don't have to do that, okay? So that's this first question. So, and be careful when you interpret this, it's a ratio of odds, okay? So it's not ratio of probability. So when you see this odds ratio of, for instance, 2.281, that's Y race for versus other race, right? So this is telling you the Y race, right, is more likely than other race to not wear seatbelt with the odds ratio of 2.281, right? Which also means the odds of not wearing seatbelt for Y race is about 2.281 times than the other race for not wearing seatbelt. Okay, same thing. Should be able to interpret this the black race versus other race. Okay, so that's cool. Okay, and the second problem asks you to run this multiple logistic regression and to see what are the significant factors, okay? And it asks you to use all the risk factor to build this regression model. Don't drop any variable, okay? You remember when we went to do the multiple regression, I mentioned that sometimes people like to have a parsimonial model. So when they run the regression, they like to include a list of variables that are all significant, right? Significantly related to response variable. But sometimes people don't do that. Sometimes people like to keep all the variable in the model, right? For some reason. For instance, for your project, term project, you need to list all the variable in the model regardless of whether the variable is significant or not significant. Because that's really the purpose of a project. You want to understand which variable are significant, which variable are not. So you will report a table that have all the variable in there. You're not doing prediction, right? You're just checking the system. What are the variable that's significantly related to response variable? And similarly, this problem asks you to do the same thing. Run the multiple linear regression with all the variable in the model, right? So what you need to do is just click Analyze, Regression, Find a Logistic. I have race in there, right? So I have to click gender in there, live on campus in there. So I select them all in there, okay? If I click OK, I will get the regression model, okay? Here, there's only race variable that was categorized, right? So again, they give you a table telling you how the indicator variable is set up. Parenthesis 1 is for indicating white, parenthesis 2 indicating black, and 1 is for not wearing seatbelt. So the model is for predicting not wearing seatbelt. So if you use this model, you'll be able to predict the probability of not wearing seatbelt. Okay, so let's go down to the last one. Okay, so you see, and there's p-values. SIG, again, stands for p-values, right? So you look at the p-value, understand what are the significant factors, what are not, right? In fact, for this data, none of the variables are significant except for gender, okay? So when you have a situation like this, you definitely want to interpret this odds ratio. This is 1.951. this actually, because gender has value 1 and 0 is a reference category. So this 1.951, it's an odds ratio for the odds of not wearing seatbelts for male versus female, because female is a base category, has value 0, right? So you can tell people that the odds of not wearing seatbelt for male is about 1.95 times than the odds of female not wearing seatbelt, right? So male is more likely not wearing seatbelt. Okay. So this makes sense. And since these other things, they're all non-significant, so there's no sense to interpret these odds ratio. There's no meaning, right? Because that different or the association not significant different, that means odds ratio is not statistically significant different from 1. That's the idea, all right? So in that's the case, usually if you write a paper, you don't bother to mention those odds ratio or interpret those odds ratio when they're not significant. Okay, so I hope that makes sense. Right. So let's see. Report the adjust odds ratio. Okay, so I forgot to mention that. All right, so all these odds ratio, now since this is from multiple logistic regression, so all these odds ratio are called adjusted odds ratio. These odds ratio you had earlier, those are the raw odds ratio. You use the information you found from the contingency table. So these odds ratio are calculated without adjusting for the other variable in the model. So these are raw odds ratio, like this thing that you report in number 1. These are raw odds ratio. Once you ran the logistic regression, you got those adjusted odds ratio, right? Those are all adjusted odds ratio. So this one asks you to report all these adjusted odds ratio and explain how each of those significant factor affecting the risk behavior. So I ask you only explain how each of the significant factors. So if there is variable that's not significant, you don't have to bother to mention them. Okay. So that's, I think if you watch my video, it seems like complicated, all right? But if you use SPSS, I hope, right? Things are easier. So you can run the regression so easy, like the linear multiple regression that you did last week. So the last one is prediction. So how do I do prediction when I have that model? So here I ask you to use a model built in equation 2. That means I like to use all the variable in the model to do prediction. Okay. So how do we do that? Let's see. Let's look at the data view. Okay. What we want to do is actually, so this question asks you to estimate the probability of randomly selected Y female live off campus, right? Y female live off campus. So just like when you're doing linear regression for prediction, at the bottom row, female, Y, off campus, 0. So female, this is 0 and 1, and this is actually 0 off campus, right? So once you enter the last row and you run the regression again and save for predicted probability, you will get the probability. So you don't have to do this hand calculation, although in my lecture video, I mentioned that, right? But you don't have to do that. So let's see how we do that. Run this again, find a logistic regression, and you save for, say, the predicted probability, and continue, okay? Before I run that, I like to do one thing, option. If you click on option, there's this Hausman-Lemon show goodness of fit test, right? This is actually a method that we can check how well the model fits the data. So if the model doesn't fit the data well, then this model may not be so useful, right? So oftentimes people would do this checking, and in fact, there are so many other methods for checking model fit. SPSS just give you this option only, right? But anyway, so if I click OK, and then go back to the data sheet, you see the last row, this number is the predicted probability of not wearing seatbelt. So if you have a female, Y female live off campus, the probability of this person not wearing seatbelt is about 0.21, so about 21%. Okay. So that's really, really, this is a really powerful method that is so popular nowadays. I think I wonder if I mentioned this in any of my lecture or not. But for instance, if you apply for a loan, right? The bank will actually have some people do some modeling like this, collect their customers' information, whether their gender, male, female, their race, and maybe there's some quantitative variable like income, right? Or a credit report, whatever, right? And then they use these information, and then also there's a outcome variable that is they have a loan default. Okay, so they can loan default is yes or no, whether you have loan default or not, you have a bad loan or not. Okay, so in fact you can actually use a logistic regression model to model the situation, and the end result is they can predict whether the person will have a bad loan, you have a bad loan or not. Okay, so if the probability of having bad loan is high, then we're not going to give you the loan. Okay, so the model is quite popular nowadays. It can be used to solve various type of problem. Okay, so I guess this question 4 is pretty easy, right? You can solve it by just few clicks. And just now I also asked you to check on the model fit. Actually, where is it? Hausman-Lemon-Short test. And this is the goodness of fit test, right? If the data fit as well, that means the model and the data, they're having the same kind of distribution pattern, no difference, right? So we like to see this p-value to be more than 0.05. It's less than 0.05 means the model doesn't fit your data well, okay? Unfortunately, SPSS only give you this as a model fit statistic, right? Maybe if you're interested in statistic, or you can look online, there are more a method that you can check how well the model fit the data. Okay. Okay, so that's question 4. And I'd like to, since we're doing this, I'd like to mention to you, let me find the lecture note. Logistic regression model looks slightly different from multiple linear regression, right? So the model is like this. If you want the model for predicted probability, this is actually the equation. You can either use this part or this part. They are equivalent, right? So probability of success in that problem we had is a probability of not wearing seatbelt. It's exponential function of linear function of x, right? Remember, when we do linear regression, we only have linear function of x. But when we do logistic regression, that model looks more complicated, right? It's actually a non-linear function, non-linear model. Okay, so that's actually a model look like. Okay, this is a situation when you only have one predictor. Okay, if you have more predictor, then this part will be a lone expression similar to what you had in multiple linear regression. So for this particular problem, when you have only one predictor variable, predicting probability of success, right? In this example, in my lecture is predicting probability of having down-gate disease is the exponential function of the constant, like a constant term. Yeah, negative 0.299 minus this. This is kind of a slope for the sector variable, negative 1.234 times x, right? So the regression equation is like this in a different form, nonlinear form. Numerator is this, denominator is 1 plus e to this. Okay, so hopefully if you have a model built and you have the coefficient here, you'll be able to, in the future, be able to use these estimated coefficient to get this probability prediction equation. So you can calculate actually the probability, predict the probability of success. Okay, I hope I'm making sense. So in the data that we have here, so in this SPSS output we have here, we have these coefficients here, right? This is this alpha, then you have a beta 1, beta 2, beta 3, beta 4, each for different variables, right? You can actually use these coefficients to write a regression equation. Let me show you how we do that, right? So this would be, let me insert the equation, okay. Maybe do this. Where did I insert? It's over here. So this is probability is that? Okay, the p hat and then equation. Then we have an exponential function, and on the this is e, and on the numerator that's actually I can start typing these things in there. Okay, e to the. If you look at this, the constant is negative 2.066, right? Then minus live on campus is negative 0.041. I'm going to call it time maybe x1, subscript 1. Well, I'll just say x1. I hope you understand x1 is just one variable. That it's, let me say L stand for live on campus, okay? And then plus 0.668 times gender. G stand for gender variable. And then plus 0.505 time, this is actually reference 2, right? That's black race. Then plus 0.765 time Y race. So our probability prediction equation will be something like this. And this is a numerator. And the denominator is 1 plus this whole thing in the numerator. So if you want to write a probability prediction equation, this is it, right? And this can be easily carried out with the Excel, if you have an Excel, right? Let me show you how do we do this calculation in Excel. So I have this complicated model, and let me bring up an Excel. I have an Excel here. Okay, good. So I'm making this Excel, doing this down here maybe. Making it bigger. Okay. I'm going to, the exponential function in Excel is like EXP, right? So you put EXP and this expression here, I can take that in here. Copy, maybe and paste. Okay. Unfortunately, these 4 places should be values, right? So I'm going to make this value here. This value is I1. So I'm going to call it I1. And I have to multiply, so put an asterisk, right? Then the G, I'm going to call it J1, which is this value here, okay? And then B, that's a black race. It's a K1. That's really this value here. Oh. And W, be L1. Okay. So if I do this, right now there's no value, okay? There's no value in I, J, K, but remember, I is for live on campus or off campus. Let me do it this way, probably better. Insert a row. So I is for live on campus or not, all right? And J is for gender, and K is for black race, L is for Y race, okay? So that's, actually, since I insert, they jump to I2, have a right reference. Now, L, remember that's live on campus or off campus. We're trying to predict a person who lives off campus, so has a value 0, right? Off on campus is the indicator variable. 1 indicating on campus, 0 indicate off campus. So if you talk about a person live on off campus, this should be 0. The value for gender is female, so it should be 0, okay? For black race, actually, this is not, right? This is a Y. Remember, it's a, I think it's a Y. Y female. Female student, right? Y female, right? So it should be Y is 1, black is 0, right? Remember, Y and black both are indicator variable. When when you're a person that is y value for y variable is 1. If that person is not y, value for y variable is 0. If it's black, then black is 1, so y is 0, right? If you talk about other race, then both of these would be 0. Okay, so this, if you enter this, actually it changed this value, right? Did it change? Yeah, it keeps changing when you're adding these numbers until you have all these value in there, right? This give you actually just the exponent part. So the predicted probability is what? Let me move this out. The predicted probability is, I'm going to calculate that, is this numerator. If you look at that formula, let me just reference that back. Is that numerator divided by 1 plus that numerator, close parenthesis. So what I'm doing here is using this numerator and divide by 1 plus that numerator. So I'm calculating this, right? So if I click enter, look at that probability, 0.214, which is exactly the same as what SPSS give us. Okay, hope this makes sense to you. Okay, let's compare this equation with the SPSS output again. Let me take this out. Compare that with this SPSS output again. When you have these coefficients, you can write this prediction model, right? Equations. It's an exponential function of this linear function of those variables. Now you're good with this, right? When you learn multiple linear regression, that's exactly what you got there. The model, actually the computer help you to estimate these parameters, these slope, right? So you can write down the regression equation. But you got to know how to put in these variables when you're doing prediction. Live on campus, remember in this problem, 1 is for live on campus, 0 is for off campus. And for gender, 1 is for male, 0 is for female. Black and white both are indicator variables. So if you have a white subject, then white should be 1, black should be 0. If this subject's black, then black is 1, white should be 0. If this subject is other race, then both of these will be 0. So that's how you actually, enter these values into the model and get the probability calculated. Okay.